Howdy, howdy, this is Mr. Potter. In today's video, we're going to talk a little bit more about the lists and using the list to do several things at once. But before I do that, I want to talk about a few of the other turtle commands that we have. And so we're going to go to sculpt.org. And we're going to go back to this. So this is the code that we had last time, and I'm going to get rid of all of it with the exception of the first two lines of code, the importing of the turtle class and the turtle constructor. And so the first thing that we're going to do is we're going to talk about a few methods that we have. So the first thing I want to talk about is the shape of the turtle. Now, last time we were dealing with what we call the classic shape. And so if I were to run this, you would see a turtle that's kind of got this wedge shape, this little triangle shaped here, which clearly shows the direction that it's pointing. And we saw in yesterday's video how when we did a turn, we did left turns and right turns, we saw this thing rotating about the point. But if I were to change this to something else, like a triangle, then I'll actually see if I could spell triangle correctly, that would be wonderful. If I change that to triangle, then I'll actually see this triangle here. And I can change this to several things, including, amazingly enough, a turtle. And when I do that, I actually end up with something that's vaguely turtle-shaped. Now, looking at this turtle, you can still see the direction that it's headed towards, the direction that it's pointing. And of course, when we change this with an angle later, you'll see the turtle moving about the point, but this actually is turtle shaped. So what I'd like you to do is to experiment with this. You can change what's inside the parentheses to arrow or turtle, which we're doing right now, or classic, or triangle, or, and this one's interesting, if I change it to circle, then I'm going to have a circle at this place. But as I rotate this turtle, as this turtle moves about, you won't really notice any rotation, because if I rotate a circle, it's not really going to change. The second thing I want to talk about is I do want to recap. Last time we were talking about color, and we were doing it in the guise of a string red. And so this would change my turtle to a red color. We're familiar with this. So there's my red turtle. And I mentioned kind of offhand that you could use the hex codes that we talked about back in Unit 1, where we have a certain amount of red, a certain amount of green, a certain amount of blue, to define your own unique color. So what I could do is I could do a hashtag followed by FF8080. And what this is going to do is it's going to give me a lot of red, a little green, a little blue, but keep in mind that 808080 would have been a shade of gray, so this is actually going to get me a lighter shade of red. So this actually gets me a nice pink turtle. And so what we can do is we can use the hex codes to user define a color in red, green, blue. But I have to remember to start this with a hashtag if I'm going to do that. And then the third thing that I want to introduce in this video is the idea of speed. We are, after all, talking about a turtle. And what we'll see when we start experimenting with this a little bit later is I can put any number in here between 1 and 10. We'll just do 5 for now. But a number between 1 and 10, 1 is slow and 10 is fast. So I can experiment with different numbers between 1 and 10 inclusive in here to make my turtle move different speeds. So I wanted to talk about these three methods, these three things that we could do with the turtle before we actually start getting into today's lesson. In today's lesson, I want to talk more about lists. And we showed yesterday different types of lists. Last time we talked about a color list. So we had a list that included red, green, yellow, and blue. What I can do is I can create a list called distance. And I can say this distance is going to have different distances in it. So I could put like 130 and 40 and 60 and 100 and 80. And I can have lots of different distances in here. And I can also create a list called angle. So I'm going to say angle gets 90, 110, 40, 160, and let's say 80. And so what we can do is we can actually have our turtle move a certain distance and then go a certain angle, and then move a certain distance and then turn a certain angle. So we can set up these lists to have a whole bunch of data that the turtle's going to use. And so we're going to use similar code to what we were doing before, but instead of talking about, things in one particular list, I'm actually going to use both of these lists at the same time. Now you may recall that I can talk about elements in this list by talking about dist sub 3 or dist sub 4. And that's going to tell me about the third item or the fourth item, again remembering that we start counting at 0. So what we're doing here is we are making a list of distances and of angles. And again, starting at index 0. And the other thing that I have to be careful of, this is one thing that I'm going to have to watch out for, is make sure the lists are the same length. And I'll talk about what that can cause problems with later on. So now in order to use these lists, I don't need to do like for C in that color list, or for D in that distance list, or for A in that angle list. What I actually want is I want a number that's going to go from 0 up through the length of this list. So we do for index in the range of the length of dist. And what this is going to do is it's going to go through distance. Distance has a length of 5. And when I do the range, it's going to start at 0. So it's going to go 0, 1, 2, 3, and 4. So index is actually going to go through the values 0, 1, 2, 3, and 4 in order. And by the way, I need to have this colon here because Python uses a colon to denote the beginning of a loop. And we're actually going to be looping through these index values. So once I do this, I'm going to say t.forward. And I want to move forward whatever distance box index is equal to. And then I want to say t.left, and I want to move whatever angle box index is. And so as index goes from 0, the first thing I'm going to do is move forward 130 pixels, and then I'm going to make a left turn 90 degrees. And then index moves to the next value. Index is 1. I'll move forward 40 pixels, and then I'll turn 110 degrees. And so I should be able to move these distances and turn these angles respectively. So let's see what that does. All right, so let's make sure we have this colon here in the right spot. And now when we run this, we'll see our turtle moving, then making its turn, moving, making another turn, moving, making another turn, and then here's our 160-degree turn, so it's almost going straight back on itself, and coming back here. Notice that it makes that turn and then moves forward. So it moves forward and then makes a turn, moves forward, then makes a turn. So it made this final 80-degree turn before it actually started moving forward. So what we can do is we can add more data points to this if we wanted to, 60, 100, and 75, and make sure that these angles are also commensurate. So let's say 70, and let's put a negative 40 in here and a negative 90 in here. Keep in mind that because I've got these set to left angles, these negatives are going to make it turn right. So here's our turtle moving forward and turning. And of course, notice because I have the speed set at 1, our turtle is being a turtle. It's moving very slowly. So there's that 160-degree turn. There's the 80-degree turn. Here's another 70-degree turn. And here's the negative 40-degree turn. So notice that here, because the angle is negative, it's turning clockwise instead of counterclockwise. Now, I did make the caveat that we need to make sure that these lists are the same. If I make this first list shorter by, say, taking off the last two elements, then the length of that distance list is only 6, which means it's only going to do the first 6 of these, and it's only going to do the first 6 angles. Let me speed up our turtle a little bit so we don't have to wait so long. So notice that it only does 6 paths. If, however, let me take this back, if I were to have a situation where I had more distances than angles, then I actually run into a problem because there's no other angles for it to choose from, and it's still going to stop short. So if I want to make sure that it actually uses all of the data that we have, we're going to have to make sure that our data sets are the same size. So once again, this is Mr. Potter. Thank you for watching. Have a great day.